Okay, so the second video that you might want to watch is a little bit more advice in terms of how to name branched hydrocarbons. So what we're going to do here is we're going to take a look at this particular what I call the process. And essentially it's just a series of steps that I go through in my mind that allows me to think about how, or identify rather, how it is that we are going to, or how something is named. So the very, very first thing that I generally do is I generally go through the process by identifying if it is straight or branched. And in this case, I can see that there are definitely branches. Like there's a branch here potentially, there's a branch here, there's a branch here, and a branch here. Now, how did I know that that's where my branches were? I just identified that there were things coming off, and that's just how I decided. So if I was going to go ahead and then find my longest continuous chain of carbons, I start counting. 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8. Now, this is a more correct structure than the straight line. And the reason why it's a more correct structure than the straight line is because the branch here, if we would have went straight across, the branch here would have been a branched branch. And we are going to avoid that in this class. When you take organic chemistry in college, you'll worry about branches, but not this time. So it's 8 carbons long. It's all single bonds. So I know that it's in octane, and the prefix is oct. And I know that there are branches. Now there are 3 different 1 carbon long branches. Which we'll call methyl. And there is 1 2 carbon long branch, which we will call an ethyl. So again, when we're naming branches, we have to alphabetize the names. So E comes before M, so it has to be ethyl methyl. Now there are 3 methyl branches and 1 carbon or 1 ethyl branch, so I'm going to use the prefix tri. So this is going to be a tri-methyloctane. And if I'm going to number, again, we have to check 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, 5, 6, 7, 8. I'm going to number closest to the first branch. So I'm going to go in this direction here. So I'm going to note that my methyls are on the 2nd carbon, the 4th carbon, and the 5th carbon. So it's going to be a 2, 4, 5 trimethyl. And then I'm going to check out my ethyl. And my ethyl happens to be located on my 3rd carbon. So YL. And it's an F because it's 2 carbons long. And that carbon and that branch happens to be located on the 3rd carbon. So it's a 3-ethyl 2,4,5 trimethyl octane. And if I were to talk you through the next one, I'm going to look for the longest continuous chain that has branches, but also contains the multiple bond. So in this case, the longest continuous, because I see branches here and potentially here, but I also note that there is a multiple bond. So I'm going to start counting 1, 2, 3, 4, 5, 6. Nope. 1, 2, 3, 4, 5, 6, 7. Maybe 1, 2, 3, 4, 5, 6. Nope. So it's definitely this, which is, we said 7. And it's got a multiple bond, and the multiple bond happens to be a triple bond. So it's an ine. Oops, that's no fun. So it's an ine. And we said it was 7 carbons long, so it's going to be a heptine. Okay, and we need to tell the world where the multiple bond is, and in this case, the multiple bond appears between the 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. So remember, multiple bond is where we start numbering closest to, so it's going to be a 2-heptine. Okay, now I need to deal with my branches. I have a 1 carbon long branch, which is a methyl. Oh, geez, I don't even know what I'm spelling there. Oops. Which is a methyl. And a 2 carbon long branch, which is an ethyl. Okay, and they have to be alphabetized. So if we started counting closest to the multiple bond, we're going to continue that. So when I go to name this, I'm going to put ethyl before methyl, so YL, and it's a meth. And it happens to fall on the, let's see, 1, 2, 3, 4, 5, the 5th carbon, so it's a 5-methyl. And then there's another branch, which we already identified was the ethyl. So it's an ethyl, and that one is on the 1, 2, 3, 4th carbon. So it's a 4-ethyl, 5-methyl, 2-heptine. Now, when you're asked to draw these structures, again, we're going to go through the same process, but there are a couple of things that we have to keep track of. So first of all, the fact that it's a 2,2,3 or 2,2,3 trimethyl butane, the A and E tells me all of my carbons are single bonded. The but is a prefix that tells me there's 4 carbons. The YL tells me there's a branch. The meth tells me it's a 1 carbon long branch. The tri tells me there's 3 of them. And the 2,2,3 tells me the location of them. So when I'm going to draw it, I'm going to start with my carbons. 1, 2, 3, 4. I'm going to single bond them together. 1, 2, 3. And then because I'm drawing the structure, I get to count it. So I'm going to count from left to right. 1, 2, 3, 4. And in this particular case, I've numbered them from left to right, and I see where my methyls are going to be on the 2nd carbon, and the 2nd carbon, and the 3rd carbon. So now I'm going to go back, and I'm simply going to go ahead and add, hydrogens. I guess we'll use gray for hydrogens, so that every carbon has 4 bonds. So H, 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 H. Okay, so every carbon has 4 bonds. Now the way that I drew it over here is what we would call the structural formation. Over here is the condensed structure. So both are correct. You just have to make sure that you identify how it is that you, well, not identify, but you have to make sure that that every carbon has contained 4 bonds. Last one that we're going to kind of try together here. So let's see. I know that the ENE tells me there's a double bond. The hex tells me there's 6 carbons, and the 2 tells me the location of the multiple bond. So it's a 2-hexene. The YL tells me there's a branch. The meth tells me it's a 1 carbon long branch. The di tells me there's 2 methyl branches, and the 4,4 tells me the location of them. There's also a YL over here, and the eth tells me it's a 2 carbon long branch, and the 3 tells me the location of it. So I'm going to start by drawing my longest continuous chain. And so because it's a hexene, I'm going to draw 6 carbons. So 1, 2, 3, 4, 5, 6. And with my bonds, what I'm going to do is I'm going to draw all single bonds. 1, 2, 3, 4, 5. I'm going to number my chain. 1, 2, 3, 4, 5, 6. And in the process of numbering my chain, what I'm going to do is I'm going to now know that because this 2 tells me the location of the double bond. I'm going to put my double bond in between my second and my third carbon. Now what I can do is I can go back and add my branches, and it's a 4,4 dimethyl, which tells me that on the fourth carbon I'm going to have 2 methyl branches, and a 3-ethyl on my third carbon I'm going to have an ethyl branch. So at this point I've put all my branches in, I've put in my double bond, and now I'm going to go ahead and I'm going to add hydrogens so that every carbon has 4 bonds. So in this case, H, H, H. This carbon has 1, 2, 3, so I need 1 more hydrogen. This carbon has 1, 2, 3, 4. It's good. This carbon has 1, 2, 3, 4. The 5th carbon has 2 hydrogens. The 6th carbon needs 3 hydrogens. My methyl branches both need 3 hydrogens. And my ethyl branch needs 2 hydrogens and 3 respectively. So that's the structural formula. If I was going to go ahead and redraw this to be like my the condensed formula, I would have 2, 3, 4, 5, 6. And then I would go ahead and I would have my double bond. I would add my branches, which over here would be on the third carbon. CH3, oops, CH3, that's not okay. Need to get rid of that 3 and make it a 2. And on my fourth carbon, I have a CH3 and a CH3. And then I'm going to go back and just add all the H's that every carbon needs. So this would be an H3. This would just be an H. That's okay, that's okay. This would be an H2 and an H3. And essentially that's it. So I hope that that makes a little bit more sense. And at this particular point, we're going to move forward with the next video.